One of the things we can build inside of NSX are universal transport zones that support universal logical switches and universal logical routers. And so then the question becomes, what does it mean to be universal? Is it like a universal translator or like universal healthcare? In this nugget, we're going to explore exactly what it means to deploy universal NSX routers and switches. So to get a handle on why we might need universal NSX switches and routers, we need to think about what we have in our infrastructure to start off with. And that's going to consist, of course, of this top-down approach. We have our vCenter server, which gets bound to an NSX manager in a one-to-one relationship. And underneath that manager, we have the objects that it controls, which include the control VM that is associated with distributed routers and the control cluster VMs that are in charge of managing the centralized distributed routing tables and distributed switching information that is shared throughout the network. And then we have our actual devices, which consist of the distributed elements of the switches, routers, firewall elements, and then we have the edge devices, those VMs that stand alone, usually on the perimeter, and all of that, of course, resides on top of the hosted physical network. And we said all that again just to remind you, all that is bound under one and only one NSX manager tied to our vCenter server. It could spread across multiple clusters, but it's all tied to one server. And when we really focus in on the distributed services, how does a service get distributed to a particular ESXi host? That's the association with a transport zone. The transport zone is what determines the communication model that's used by default. Is it going to be unicast, multicast, or a hybrid approach? And essentially, it is the middleman between the various lists of ESXi host clusters and the various different logical switches and routers that are associated with that transport zone. So the transport zone is that connective tissue between those two elements. And all of that works great as long as I have one and only one vCenter server in my environment. But when we distribute and have multiple vCenter servers, then we're going to run into a problem because our VXLAN is going to hit a hard wall when it tries to communicate with anything outside of the vCenter server environment. Anything that is a node, that is a part of a cluster, that's not managed by this vCenter server is just straight up out of luck. Unless we built something that could traverse this entire environment, that had extra properties that allowed it to navigate between vCenter servers. Properties that wouldn't normally be necessary, but that could be used to circumvent this situation. And that's exactly where universal NSX routers and switches come into play. So let's add this idea of a second instance of an NSX manager with its vCenter server and its routers and its distributed services, right? Everything repeated all over again. But now we want to have the ability to come to a common understanding of a particular VXLAN and a logical switch that's able to support it. So as we envision various different VMs that might be attached to a particular switch, if we have a VM attached to the equivalent switch, we could have end-to-end network connectivity, VTEP accessibility all the way to a device that was managed by a separate vCenter server. An ESXi host can belong to multiple transport zones. But any particular VXLAN, a logical switch, can only be associated with one and only one transport zone. And in fact, within any NSX environment, we can create multiple global transport zones, but we can create one and only one universal transport zone. But when we build VXLANs and associate them with that universal transport zone, and we have ESXi hosts that are associated with that universal transport zone across separate vCenter servers, then we can share in that same configuration and have that end-to-end configuration that we want. This configuration will end up with one of our NSX managers being described as a primary manager and another one being the secondary manager. We'll create our universal objects in one and replicate them to the other, and then we will have this universal capability that we need. Universal transport zones are there for one core purpose: to be able to span cross vCenter NSX environments. If you don't have that need, then global transport zones will fill all of your needs. And when we think about this idea of having universal VXLANs that are able to go cross vCenter, it's not just the knowledge of the VXLAN itself, but knowing how to use it, which means sharing information like the ARP tables, the MAC tables, and of course those VTEP tables to know where the ESXi endpoints are that support this. And if we add distributed routing, of course, the routing tables as well. My friend, by going through this nugget, you've learned when and why you might need universal NSX switches. It's all about this cross vCenter NSX support and being able to have end-to-end connectivity for VMs that share the same VXLAN. My friend, I hope this has been informative for you, and I'd like to thank you for viewing.